In this part, we have the bowling ball rolling without slipping down the return ramp at the side of the alley. Now, then it says that the ramp is inclined at the angle beta to the horizontal. The question is, what is the ball's acceleration and what is the friction force acting on the ball? Now they're telling us that we have to treat the ball as a uniform form, solid sphere, ignoring the finger holes. Now, with the graph given, we have a couple things. We have the normal force going upwards in the y direction, and then we have the radius up here. Below the radius, we have a friction force, and then we also have an angle theta. Angle beta, which is the same as this angle that is shown here, just differently drawn. Opposite to the angle beta is going to be this sign. This thing right here, which is opposite, represents the trigonometric function sign. Now, additionally, we have this sign represent mg cosine of beta. Then a couple useful formulas that we're going to use to solve this problem is going to be the moment of inertia of the center mass being equal to 2/5 mr squared, and the acceleration of the center mass in the x direction is going to be equal to the radius times the angular acceleration. Now this is the formula for the moment of inertia of the solid sphere, which we're dealing with right now. Now the problem goes like this. The sum of all the forces is going to be equal to mg sine of beta, this sign right here, or this one. This is better. Mg sine of beta times the frictional force, which in this case is going to be static. One going to the left and one going to the right. That's going to be in the x direction. In this case, the frictional force is going to be negative, and the mg sine beta is going to be positive. That's going to be equal to ma of the center mass. Additionally, we have the sum of the torques being equal to the static force times the radius. And that's the same thing as the moment of inertia of the center mass times the angular acceleration, which we said it was 2/5 mr squared. Now, if we rewrite this equation, we end up with the angular acceleration being acceleration of center mass in the x direction divided by the radius. So we got the moment of inertia this way, and the angular acceleration right here. As we continue to solve the problem, we can cancel out some r's, and then we can say that the frictional force is going to be 2/5 of the mass times the acceleration of the center mass. And then as we continue solving this problem, we end up with 2/7 mg sine of beta for the frictional force, the static force. Now to find the acceleration, we just use this equation, the sum of all the forces in the x direction, and now that we have the frictional force, we can solve for ACMX. Just rewrite it right here. We give the value for frictional force, and we cancel out some mass. Then we end up with the acceleration of the center mass in the x direction being equal to 5/7 g sine of beta.